Uh, can someone confirm if I am audible?
You are audible.
Okay, ठीक है. So let's wait for 5 minutes or so. Let's other join and then we can start the class. Okay, so let's start the class then. Let me share my screen. If someone can let me know if the screen is visible. Okay, ठीक है. So let's start the discussion. Okay. So we last class we saw matrix inverse, and we saw that if A into B is equal to identity, B is called A inverse of A. So, and we saw different properties, and A inverse of inverse was, what was the value? What is the value of this? What is the value of this? This one?
A, sir.
Yeah. So everyone remembers this thing, right? That how did we derive this part and how did we associate? Okay, so now we will see, uh, we will move forward. This form of matrix inverse, the adjacency matrix, we will not look into this, but I'm assuming that most of you are familiar with it. But in general, we don't do A inverse now, no longer do this way. There is Gauss elimination method that we generally try using. But this is also one way of finding A inverse. Let's look into something more important that we have to do. So how do we solve the equation system of equations though? So if there is like a simple linear equation, say 2x is equal to 10. What is the value of x?
So 5.
5, right? So how did you do? It was simple, 10 by 2, correct?
Yes,
Right?
sir.
So this part can also be written as x. If a is not equal to 0, then you can always write this part. You can see A inverse B. Then there is exactly one solution, A inverse B. So this part you can also write x is equal to 2 to the power minus 1 into 10. Right, 2 to the power minus 10 is 1 by 2 into 10 is equal to 5. Right? So you can always write in this form, and this gives you a single solution. And similarly, when A and B both are equal to 0, so what is the solution for this then? Okay, so what is the solution for 0 times some, say, y is equal to 0? What is the value of y? What is the value of y? Anyone?
1, no, sir.
1. Okay. Anything else? Or only 1? Anything else? Anyone thinks it can be anything else, or 1 is the correct answer? Okay. So what about y equal to 2? Is this correct answer for y equal to 2? 0 into 2 is equal to 0. So this equation for 2 also this equation satisfies, right?
Yes, sir.
What about 3? Is this equation for y equal to 3? Is this equation correct?
Yes, sir.
And therefore, what is the value? What is the correct answer for y?
Infinity, sir.
Yeah, there are not infinity. There are infinitely any value for any value for any real number, right? So you know what real number is, right? Like 1, 2, 1.5. So from minus infinity to infinity or plus infinity is say, so this is your number line, and so this is your zero somewhere in between. So any value, y can take any value on this number line, right? Y can take any value on this number line, and this equation is correct. Correct?
Yes, sir.
So this means that so for equation when a equal to 0 and b equal to 0, then it becomes 0. So any value of x will do. So any value of y on this number line, and this number line is represented by this r, by represented by a real r. So when you see this r, it simply means this real line. So for this, the solution for this y is y belongs for any y. So how do I type inside? Any y, any y in R. Uh, so this much is everyone is okay with this, right? So when 0 y equal to 0, the solution of this is this, right? Everyone is with me for this part?
Yes, sir.
Okay. So now let's look into the another case. When what is the value of this 0 into, say, we call it z is equal to 2. What is the value of z? Value of z is, what is the value of z? One, two, 5. What is the value of this z or z? Can anyone say?
Sir, I
Yes.
think undefined because 2 by 0 is undefined.
Okay. Not undefined is okay, but it is like there is no solution. No solution.
Yes, sir.
Why? Simply you try putting verifying it. 0 into 1. What is the value? 0,
0, sir.
right? So anything, any real number you multiply with 0, it will become 0. So z into 0 will become 0, right? And 0 cannot be equal to 2. So for any value of z, we cannot satisfy this equation. No solution. This much is okay?
Yes, sir.
So everyone is okay with this part? So there are 3 conditions. When a is not equal to 0, then you can find by saying a by b by a or a inverse b, better a inverse b. When both of them are 0, then you say that there are infinitely many solutions. So there are like almost any value you put, it will always satisfy. So infinitely many solutions. Solution. Here you have single solution, only one solution. Okay, let me just delete certain part. Let me just delete. So in the first case, you have one solution when a is not equal to 0. When both a and b are 0, you have infinitely many solutions. And when a is 0 and b is not 0, you have no solution. No solution. Is this okay? No. This makes sense? Any doubt till at this point? So let's do one more though. Say 2x is equal to 0. What is the value of x? Am I audible?
Yes, sir.
So 2x equal to 0. What is the value of x?
I think 0, sir.
0, right? So there is only one solution here. There is not infinitely many solutions. There is only one solution which will make it 0. So this belongs to this category when a is not equal to 0. So a is equal to 2 and there is only one single solution. And when both the terms become 0, then you can see that there were infinitely many terms 0. So like 0 x is equal to 0. Now x has infinitely many solutions. X belongs to x. Yeah, this x belongs to this r. So you can choose any number on this real number and it will satisfy. And similarly, when a is 0 and b is not 0, then there are no solution. Okay, so now this is on the linear scale. So when a and b are everything is like a single value. But what about if you have like a set of linear equations? So what about there are n number of equations? So for example, consider this equation. So you have 2x1 plus 3x2 equal to 5 and x1 minus 2x2 equal to minus 1. And if you see, you can write this entire equation in this matrix product form. So 2, 3, 2, 3, 1, minus 2, and x1, x2. And if you multiply this equation, so 2 times x1 plus 3 times x2, 2 times x1, 3 times x2. So it will. So can someone tell me what is the matrix product of this? Let's write the matrix product. So this matrix is of size. Okay, let's do something. I'm saying that this equation can be written in this form. Can everyone see that this equation can be written in this form? Or should I explain this thing that how can we write this form? Should I explain or everyone can see this thing? Oh, this is not 1 and 5. This is incorrect. It should be 5 and minus 1. 5 and minus 1. Hmm. Can everyone see that this equation can be written in this form or should I explain?
No, sir, it's fine.
Okay, so you can see that this matrix product, if you do this matrix product, this A and X, if you multiply this, you can see this matrix will become, first of all, this is 2 cross 2 matrix. A is 2 cross 2, X is 2 cross
2
1.
cross 1.
So the resultant, if you multiply this thing, it will become 2 cross 1, right? So if you multiply this, it becomes 2x1 plus 3x2. The first term, the last, the next, second term is x1 minus 2x2, and we are saying that this vector, this is a vector of size 2 cross 1, is equal to this vector 5 1, 5 minus 1. So the first term should become equal to 5 and the second term should become equal to minus 1. And that's how you see there are these, this vector 2 3, this matrix 1 x1 x2, and then there is 5 and minus 1. It is not correct. This is 5 and minus 1. So if you have this ax equal to b, if you want to find x, then simply you have to do a inverse. If you multiply both sides with a inverse, a inverse into a. If you do multiply a inverse both sides, what is the value of this a inverse into a? What is this a inverse into a?
Sir, I.
Identity matrix, right? So it becomes identity. And identity into this vector x, what is the value of this? Identity into x. I remember that I gave this homework though. In identity into x, what will it become? Okay, let's do this thing. So let's write this identity matrix. We have one. I will just do it for size 2 cross 2. So this is a size 2 cross 2 identity matrix. And if you multiply with any vector, say x and y. So what is the first number? What should I write here? What did it become? What should I write here?
1x.
1x plus
1x plus 0, sir.
1x plus 0y, right?
Yes, sir. Yes, sir.
Which becomes x.
Yes, sir.
And the second term, what should I write here? Is there any other term that I should write here?
No, sir.
No.
No, sir.
And here, what should I write?
Sir, only y will become.
Only y will be there. So you can see that if you multiply an identity matrix with any vector matrix, it becomes the same. It remains same, right? It didn't change anything.
Yes, sir.
So I into x will become x, right?
Yes, sir.
This
Yes,
is
sir.
this is what I wanted you to see, that if you have like identity matrix of size n cross n and a vector of size, any vector of size n cross 1, the vector will remain the same. So what I want to say is that, say you have an identity matrix of size n cross n. So you are able to visualize n cross n identity matrix, right? All the diagonals will be 1 and everything else is 0. And if you multiply with a vector, x vector of size n cross 1, the output will be
n cross 1, sir.
yeah, n cross 1, but the same vector n cross 1.
Yes.
So this is, I will leave this part for you to verify. So this is an exercise. Please verify this. Verify. This is very difficult to write. Okay, so this is what I will leave it to you to verify. So now coming back to the same part. So you have Ax equal to B. So you have written A matrix into X vector is equal to some B vector. Now if you multiply A inverse both sides, so you multiply A inverse into Ax is equals to A inverse into B. Is this correct? This part is okay. So you just simply multiplied A inverse both sides. Now this part became identity matrix. A inverse into A becomes identity into X is equals to A inverse B. This is okay.
Yes, sir. Okay,
Now
sir.
identity into X is X. X is equals to A inverse B. This part is okay.
Okay, sir.
So now you can see that if not just only these two equations, if there are like hundreds of equations, say you have 100 such equations, like, and you have 100 such variables, x, 1, 2, say 100, x 100 variables are there, and you have 100 such equation, right? So now the matrix A is of 100 cross 100 matrix. You can write this 100 cross 100 matrix, right? Because there are 100 such equations, you can simply put all the coefficients one at a time and all the variables here. So you can write a if there are 100 equations, you can always create 100 cross 100 matrix. Can everyone create this A matrix if there are 100 such equations? If I give you 100 equations, you can write this A matrix.
No, sir.
Oh, you are not okay. So let's do one example, and we will write. So say if you have these two equation and the third equation, so let's write plus x3 and plus x3 plus 2x3. So there are two equation, x3 plus 2x1 plus 3x2 is equals to 5, 2x3 plus x1 minus x2 equals to minus 1, and then there is another equation that I will write, x1 plus x2 minus x3 is equal to, some say call it 10. Sorry, 10. So let's write. So once we write ax equals to b form, then finding x is simply equals to x equal to a inverse b, and then we know how to work out how to take inverse. There are like the other one way is to do uh, conjugate thing, but for no, not conjugate, the inverse calculation, but there are other ways too. But once we, if somehow we are able to calculate estimate a inverse, and then we will just simply multiply a inverse and b vector, and then we know how to do matrix multiplication. So finding x is much easier if we can write this a x equal to b form, right? Everyone is actually clear with this, that if we can write ax equal to b form, then finding the value of x is very simple. Just you need to multiply with a inverse b. Is this clear though?
Yes,
Yes,
sir.
sir.
So now the only goal that we want to do is that how can we find, how can we write this equation, that these three equations that I wrote, x3 plus 2x1 plus 3x2 equal to 5, 2x3 plus x1 minus x2 equals to minus 1, and x1 plus x2 minus x3 equals to say 10. How can we write this in a matrix form? This is the goal here. Okay, so let's write a matrix. So please help me write this a matrix. How should I write? Such that we know this is x1, first is x1. This is just a sec, 1 second. Oh, okay. This becomes okay. So let me rewrite this equation. Sorry, let me rewrite. So this is, you have x3 here plus, so you have 2x3 here plus, and you have the other equation, x1 plus x2 minus x3 equal to 10. So let's write matrix A. So I'm writing matrix A now. Okay, in this form, ax equal to b form. So I want to write this matrix A, this big matrix, whatever the big matrix is, and I want to write x. X is simple. What is x? x1, x2, and x3. Everyone is with me, right? So writing
Yes,
x is
sir.
very easy. B we don't. B we need to write. Which one you want to write first? B is easy or A is easy? So let's write B. What is? No, let's write first A. So first term, what should I write here? The first term. What you want to do is that when you multiply it with a row with x1, x2, x3 column, it should give you the first value. So it is say B is easy. Let's write B. So we have 5 here. Another term. What is the other term? What should I write here? -1 here. Let's write -1 here and 10 here. So what are these terms that I wrote? It is equal value 5, -1 and 10. This is what I wrote at B. 5, -1 and 10. This is what we want, right? So the goal is that if you multiply the row, the first row, and multiply with the column of x1, x2, x3, it should give you 5, right?
Yes.
So what should I write the first element? What should be the first element? This is the equation. How should I write the first element? What should I write?
2,
2,
1, 2, 3.
no, no, no.
2,
It
3,
2,
1, sir.
2, 3, 1. Why it is not 1 first? Everyone is able to see 2, 3, 1. It should be 2, 3, 1. There should not be any other way. You must write 2, 3, 1. There is no other number that you can put.
Yes, sir.
2 into x1, 2 into x1 plus 3 into x2 plus 3 into x2 plus 3
1
into
into x3.
x3 is equal to 5. The first term. What is the second term? What should I write?
1 minus 2.
Minus 2, 2.
1 minus 2 and 2. And you can see 1 into x1 minus 2 into x2 plus 2 into x3 is equal to minus 1. Now the last step, what should I write here?
Sir, 1, 1 minus
1,
1.
1 minus 1.
So now everyone is able to see this thing. And now once you have this, you just need to multiply A inverse B. Right? Estimate the value of A inverse and just multiply with this vector and you get your answer. Everyone is clear with this part?
Yes, sir. Yes, sir.
Okay. So now if I give you not just 3 equations, say if I give you 100 such equations, now can everyone will be able to write? Like there are 100 linear equations, you will be able to write into A into X into B form?
Yes, sir.
Can you write, right? Now what is the, now if I just make it say 7x4, just making it more complex, plus, no, there is no x4 here. There is no x4 here. And you have, there is no x3 here. Let's write this equation. And okay, let's write this. Let's do one more. And one more, and then we will call it a, then I will assume that everyone is able to write. So you have 7x4 plus 2x3 x1 plus this is so dumb, x2 minus x3 equal to 10, and one last equation, x3 minus x4 plus 2x1 equal to 5. Let's write matrix A. One more, and then then I will know that everyone is able to write. So we need to write this matrix A such that x is equal to what? What should I write? x1, x2, x3, and x4. And B is equal to, what is the first term? 5
Minus 1.
minus 1, 10,
Then 5.
and 5. Now let's help me write this matrix A. What should I write the first equation such that it becomes equal to 5? What should I write here?
3,
2,
0, 7, sir.
3, 0,
7.
7.
7.
Everyone is able to see this thing, right? I don't have to explain
Yes,
this part. Okay. Now the second equation.
1 minus 2,
Minus 2.
Huh?
0, sir.
2 and 0.
Then 0.
Okay. X3, the third equation.
1 minus 1, 0, sir.
0.
Okay. And the last one.
0.
0, 1
0,
minus 1.
0, 0.
2,
2.
2, 2. Okay. 2,
0.
0.
0, 1 minus 1.
Okay. So now everyone can write. And now I am sure that if I give you like 100 such equation, everyone will be able to comfortably write the matrix A. Ax equal to B form, everyone will be able to write. And you just need to invert this matrix and you will be able to find all the values, all such unknown values. Correct?
Yes, sir.
Okay. So now I feel comfortable that everyone will be able to do this thing. So everyone will be able to write Ax equal to B, and once they write Ax equal to B, x is equals to A inverse B. That's it. As we did in the last time, that it's a linear. If there is like 2x equal to 5, everyone knows that the x value is 5 by 2. It's very easy to do in just single equation. But if you have n such equation, now you can also write in this form A inverse B. We just write Ax equal to B and just invert A, and that's it. This is your answer. Okay, so now let's move on. So how do we solve this form? So how there is another nice way of solving this equation. So we will just go into one operation in the matrix operation. We call it a matrix row matrix operation, and in general, this is the best we can do to find A inverse. A inverse is much. It's called Gauss elimination method, and let's do one. So if you have this 2x plus 3y equal to 8 and x minus y equal to 8, what you simply do is that you multiply the third row with 3 and it becomes 3x minus 3y equal to 24, right? You can see this part. You multiply your equation 2 with 3 and you get this equation, right?
Yes, sir.
Okay, so what we first learned is that you can just do this way. This is called direct form. This is like A inverse B. Now there is another way of solving Ax equal to B form is called a Gauss elimination method. So we are learning a different method now. So this is method 1, which is nice and simple. And now we are learning method 2. So first we are actually just first we're just simply seeing what are these things. So if you multiply 3 equation 3, it becomes this. And then if you add these two equations, it becomes 5x plus minus 3y equal minus y equal to 0 equals to 32. This is all okay, right? Everyone is okay with these three steps,
Okay, sir.
right? Okay. So now what we see is that we want to convert. If you look at each of these equations, this equation, this equation, this equation, the value of x, the solution for this, say whatever the solution for x and y for this equation would be, is it the same solution for x and y here? Say you get some x and y, the solution of after solving you get say x star, some x star and y star. Like if you put this value here, it will satisfy this equation. The solution for this equation is also the same solution,
Yes, sir.
and solution for this equation is also the same solution, right?
Yes.
The same x star y star will satisfy this equation. The same x star y star will also satisfy this equation. The same x star y star will also satisfy the same this equation too. So all these three equations, all these three system of equations will be satisfied by this x star and y star, right? So let's see what are we doing. So if we rewrite this equation, this 2x plus 3y equal to 8, x minus y equal to 8, we can write it in the matrix form again, right? This matrix form we can write. This is A, x is hidden. This bar, you assume that x is always hidden. Okay, assume this x is hidden here. This is a correct equation. This is the correct matrix equation, and this is B. Can everyone see 2x plus 3y equal to 8, x minus y equal to 8 is this equation, this matrix equation. This is a short form of writing Ax equal to B. X is hidden because we don't need X. We just need this matrix A and B. Everyone is with me till now?
Yes, sir. Yes,
Okay,
sir.
so we can write this equation in this matrix vector form. Assume that X is hidden. We are not writing X here now. If we multiply 3 times row, this equation is exactly this equation. This matrix vector is exactly like this. So we can just simply multiply 3, the entire row, and this equation, these two are same. These two are exactly same, right?
Yes, sir. Yes, sir.
Now if we add row 1, this entire row 1 with entire of this thing, now this row 1 with this row 1, it becomes this matrix, and this is equal to this equation. Row 1 add, if you add these two rows, you get this, and these two equations are same. Everyone can see?
Yes, sir.
Okay. Now once you get to this point, the value of x is very simple. The value of x is 32 by 5, right? The value of x is 32 by 5, and the value
Yes,
of
sir.
y you can just estimate by putting 32 by 5 here, and you can in the first equation you put the value of x and you get the value of y, right?
Yes, sir.
Similarly, so once you reach into this form, you can start estimating the each value of x and you get the value. So in matrix vector product 2, so this form, like what you did, like the row operation, you multiply some numbers, you keep on multiplying on all the row element, you can add and subtract. It is actually a equivalent equations, all the form that you did. So what is the purpose? What was I trying to do? What I was trying to say that even if you multiply n, in n is a number, n a number, to all the row of this, the solution will not change. Correct? If I multiply
Yes.
with say 100 minus 100, 800, the solution for this equation, whatever this equation, and this n 100 minus 100, 800, the solution is exactly the same. It does not change the solution. Even adding these two rows did not change the solution. Make sense? You
Yes,
see,
sir.
everyone is able to see this thing, right? Multiplying a row and adding a row is not changing the solution.
Yes, sir.
Even not just that, even if you now tell me, we do something more interesting. Look at this matrix. Will the answer? No, okay. Let's look at this matrix. Look at this matrix. Okay. Now tell me, if I write this matrix 3 minus 3, 24, 2, 3, 8. Will the answer? Will the solution change? Is this equation and this equation, or maybe this equation, will the solution change? First,
No,
everybody
sir.
know, right? The solution will not change. It's simply you just wrote the second equation at the top and the first equation at the bottom. We did not change anything though.
Yes, sir.
It is still x1. Try thinking. There is x1, x2, right? 3 times x1 minus 3 times x2, which is this, equal to 24. Similarly, 2 times x1 plus 3 times, oh, there is y. 2x plus 3y is equal to 8. It's the same equation. So even changing the rows, even we changed the row entirely, it did not change the equation. It did not change the solution. Sorry, it did not change the solution. Equations are changing. Look at the equations are changing. This equation and this equation is different, but the solutions are exactly the same. So multiplying with a number in a row, adding a number. So in this case, we add 2 plus 3 is 5 and 3 minus 3 is 0. 8 plus 24 is 32. So even adding two rows did not change the solution. Even swapping the rows, like we swapped two rows, the second row became the first row and first row became the second row. Even swapping did not change. Multiplying scalar did not change. Adding did not change. Similarly, even subtracting will not change, because it's simply subtraction is like multiplication by a number and then adding, right? So subtraction will also not change the equation. Everyone is okay with this part. I will wait for a minute. The solution will not change even if you multiply a number on a row, add two rows, or even swap two rows. And similarly, we can say for the same thing, if you subtract two rows, the solution will not change.
Fine, sir.
Okay, so everyone is okay. So let's move on. So this type of method is called Gauss elimination method. And in general, why are we doing this? Because Gauss elimination methods are much easier to implement. In code, if you see, in code, even if you're not able to see that how is it easy to implement, it's actually much easier to implement. But we just know that these things are exist though. In general, when if you are able to write in this ax equal to b form, finding solution is very easy. You just inverse and into multiply with b, the solution comes. And yeah, so this is what we have. Any questions that we have now? We can go. If you have any questions, please let me know. If any questions. Any question so far?
No, sir.
Okay, okay. So now let's move to the other part though. So now we will actually see uh, Python programming, that some hands-on tutorial. So please let me know if this is visible though. If this size is visible to everyone, or should I increase the size? I think this is too big. This is too small. Is this size visible?
Yes, sir. It's visible.
Okay. If it is not visible, I think on your screen you can actually increase this the size of the view or something. You can change the view on your side too. If I'm
Okay,
not
sir.
okay. So let's start though. So we will first look into a NumPy though. How many of you are familiar with NumPy? People familiar can say I am familiar or yes, no, something. How many of you are familiar with NumPy? I am looking into chat though. Uh, Anyone? Even one person? 2%? Acha, okay. So I'm assuming people are not familiar with NumPy. So NumPy is a mathematical, how do I say, it's a library though. And we generally use this library to do all these matrix things that we did, all these matrix problems that we solved, right? So we use NumPy to solve all these matrix product, matrix solution, anything that you have to do with matrix, we generally choose to do with NumPy. And NumPy is a very great tool. It has matrix multiplication, addition, division, even inverse calculation, everything you can do with NumPy. You don't have to, you just have to call this numpy.inverse and it will invert the matrix, and we will see all those things here now. So we will go with today's tutorial is on NumPy and Python, and we will do linear algebra with NumPy. So we first start with we import the library. How many of you are familiar with Python? Like you have some information. Oh yes, yes. Oh, so there are people who are familiar with NumPy then. How many of you are familiar with Python? Is this the answer for familiarity with Python, or is this the answer for familiarity with NumPy? Can someone say if they are familiar with NumPy, Python? Yes for Python or NumPy? Both. Okay. So both. Everyone is familiar. Not everyone is familiar. Few are familiar with Python. Everyone is familiar with Python. Some are familiar with NumPy. Correct? Or everyone is familiar with Python and NumPy. So everyone is familiar with Python and NumPy.
Yes, sir.
So
Yes, sir.
anyone who is not familiar with NumPy and Python? Anyone not familiar with NumPy? Only NumPy. I don't know about NumPy. Okay, okay. So then I think we will go over NumPy too, and so that everyone is, so those who are familiar, it will be a recap for them, and those who are not familiar, I think they hope they will learn NumPy. So what we do now in NumPy is that this matrix that you see here, so you can write np.array, it will create, array is simply a matrix generator. So it will generate a matrix of size this. So if you call np.array, and if you write these two double bracket, it actually creates a matrix of size 10. What is the size of this matrix? If I don't, let me just, what is the size of this matrix?
2 cross 4, sir.
Everyone is able to see, right? It's 2 cross
Yes,
4.
sir.
So you can see the matrix reading. So there is this outer bracket, and the first term that you see is called the row, and this is a second row, and 10 4 is the one column, minus 1 and 2 is another column, 0 6 another column, 0 and minus 6 is another column. So there are 2 rows and 4 columns, and therefore the shape is 2 cross 4. So 2 comma 4. Okay, so if you want to find the shape of a matrix, you just call a dot shape, and it will tell you the shape of the matrix. You see, since it's a matrix, if you had just this list, since everyone is familiar with Python, if you have just made this list, so let's write A is equal to this and print A, it would make it this form. And if you write shape or anything, it will not give you a shape or anything, because in list you don't have shape. What you have is in list is called length, and it will only tell you what is it? It will only tell you that there are two elements in this list, but it is not what you want. You want the to read it as a matrix and then tell you the information. That's why we need to use this numpy thing, which actually deals with array. Simple list will not be able to help you. Okay, so this is how arrays are created, and the shape. If you want to know the shape of this array, so a dot shape, and it will give you the shape of the array. Now, how about this? Okay, let me just clear all output. So let me just do one more thing. I think runtime. Hmm. Okay, did not delete everything. Okay, clear output. Yeah. 1 second. Let me just clear this output so that otherwise everyone will be able to see the answer before it. I could ask anything. So let me just delete everything. Hmm. Just a minute. Okay. So now we are ready. I think I have removed everything. So now those who know NumPy, you can try answering these questions, and those who are not, those who are new to NumPy, you can also try and see if you can see the solutions though. Okay, so now let's call it a dot reshape is called a matrix, and now what we want is that, oh, this should be dot t. Okay, so now can someone tell me what is the shape of a reshaped? What did we do? What does a dot t means? It's called transposed.
Transpose, sir.
Yeah. So can everyone see that if we do transpose, the column should become the row. So 10, 4, minus 1, 2 becomes row minus 1, 2. 0, 6 column became 0, 6 row. 0 minus 6 became 0 minus 6. If you have written a in a list form, you cannot do transform, because in list you don't have transform a transpose thing.
Yes, sir.
That's why you need this numpy array. I'm repeating again that why do we need numpy altogether is because now you want to do matrix manipulation, and numpy helps you, is a library to do matrix manipulation. So to do transpose, you just write a dot transpose. It will convert this matrix A into its transpose, and you can see the A transpose is exactly this, and the shape of this, or the shape is 4 rows and 2 columns, 4 comma 2. Everyone is okay with this?
Yes, sir.
Okay. Now, someone tell me what is the element number A of 1 comma 2. A is this. Okay, let me delete this. Just reshape is equal to A now. What is this A12? What is the value of A12?
-1, sir. -1.
Minus 1. Anyone else wants to try something else? Okay. So everyone is okay. Everyone sees that it is -1.
Yes, sir.
People who are familiar with Python and NumPy, they also think it is -1. Okay, I'm assuming they are also saying yes, because they generally message though, or I don't know. Okay, okay. So let's see what is the answer. It's actually 6 though. Why did it become 6? It's not -1. Okay, the reason is that in Python, things starts from 0, not from 1. Remember that I told you that in before in the class that even though we are doing 1, 2, but it starts from in programming. It start the first index is 0 and the second index is 1. So 1 comma 2 is, so you need to go 0, 1, and 2 is 0, 1, and 2. So it's 6. Everyone can see this thing. Should I repeat?
Fine, sir.
Okay.
Yes, sir.
Okay. So now if we change the value of 1 comma 2 to 10, the matrix A becomes this. So you can see that the this 6 has become into 10, right? So you can change the element number by keeping the entire matrix same. So this is how you can change the numpy element. Okay. So moving forward. Okay, so to generate a random integer, so if you want to generate some random integers, so in NumPy there is this. First, you need to generate a random number generator (RNG). It's called a random number generator, and then you call a random int between 0 and 10. So it will generate a random number between 0 and 10 of size 5. So let's see what does it mean. So if you generate this, it will generate random number between 0 and 10, and it generated 5 random number. Similarly, you can say that, oh, okay, I want to generate not between 10, I want to generate between 0 and 90 and 5 size, and you can see that it will generate 5 such number between 0 and 90. You can make it even more drastic, that you can ask it to generate 20 such number and it will generate you 20 such number. So random integer, rand int can help you generate random numbers between some range and of size. Say if you do not specify size information, it will generate one random number. If you tell the size is say 2, it will generate an array. What happened? Why is it? It generated 2 random numbers. Okay, so this is what random number generator does. Now, if you want to generate not a random number between 0 and 1, but a random number between 0 and 1, so you call random, not random, but random, and of size 3. So it will generate a random number between 0 and 1 of size 3. So you can see 0 and 1 number between size 3. Everyone is okay with this part?
Okay,
Yes,
sir.
sir.
Okay. So now we are able to generate random number between 0 and 1, 0 to some number, and a random number between 0 and 1. So this is very straightforward, and you can generate as such numbers easily.
Okay, sir.
Acha, there is a one interesting question that I want to ask. Say if I give you this, say I was able to generate, I will give you that you are able to generate random integer between 0 and 1 of size, say I want size 5. Now I want you to generate random number between 0 and 1 by using rand int only. Can you help me generate this? So I want you to, I give you this number, I can help you generate this number. You generate 10 numbers between 0 and 5. How can you generate a random number between 0 and 1 just by rand integer? How? What should I do? So print random integers. So you can see that this is the random number between 0 to 10. How can I generate a random number between 0 and 1 by this vector? How can I convert this number between 0 and 1? What should I do? Any thought? What? How can you generate a random number between 0 and 1 by just using rand int?
Random.
Huh? No, no, if you use random, then hey, you're just finding a number between 0 and 1. I'm asking you, you cannot use random. You only have this random integer thing. And can you generate a random number between 0 and 1? Only by using random. There is nothing, you cannot use random. You cannot use this random. You only have to use this thing. How can you generate a number between 0 and 1? So let me give you a hand. If I do this, will it help? Will it help you generate random number between 0 and 1? No, yes. Yes, right? You can generate, you can start generating random numbers even by using this. Obviously, the decimal points, the decimal points you may not be able to, but I can generate even the decimal points. I will show you how. But you can see that you can generate random numbers if you only use the random number generator 0 to 10, and if you divide by 10, it's basically you are dividing everything by 10, and it becomes a random number between 0 and 1. Can everyone see this thing? That by using random number integer generator, we are able to start generating random number between 0 and 1 by doing this, by dividing by 10. No, yes.
Yes, sir.
Okay, so what if I but look at the decimal. There is like only one decimal you are able to generate. There are so many decimals that they were able to generate. What should I do if I make it 100? So first I generated random number between 0 and 100. And what should I divide this number with so that it becomes a random number between 0 and 1?
Sir, 100.
Exactly. Because the maximum number it can generate is 100, and you want the maximum number to be equal to 1. And the minimum number you want to generate is it can generate a 0, and you want the minimum number to become 0. So the 0 division is not needed. You only want the maximum number, that is 100, to become equal to 1. And how will it become equal to 1? When you divide the maximum number by the maximum itself. So you divide the maximum by 100, and it starts generating a number between 0 and 1. 0 and 1, right? Now you can see that it is only able to generate two decimal though.
Yes.
So if you want to generate a random number between 0 and 1 of 4 decimal, what should the random number integer should be?
Sir, 10,000.
Exactly. And what should I divide it by?
10,000, sir.
And there you see that you have this 4-digit things here. Here you can see the 4-digit is 0, so don't feel like, oh, it is only 3-digit. The 4-digit is 0. Everyone is able to see that now you can generate, even if there is a random number integer you can generate, you can always generate a random number between 0 and 1 by scaling. Uh, Anyone who has doubt or not able to follow, is okay?
Yes,
Yes.
sir.
Okay.
Sir.
And especially the person who is not familiar with NumPy, I would request that if she can say if this is she's able to follow or not. People who are not able learning NumPy for the first time, I would request them to participate more. Okay, so this is how you generate random numbers, and why you need such random numbers. There are n number of application in machine learning why you need to do such thing. So just know that this is also you can do. Even if you've forgotten how to generate random number between 0 and 1, you can generate numbers between from here and go back to here. Okay, so now let's look into something called rank of a matrix. Actually, this we have not dealt with, but we will come to it again. Okay, we will see. So if you have this equation though, so 2x1 minus 2x2 plus 2x3 equal to 6, this complicated three equations, can everyone see that this is the matrix that this equation will convert into? I will wait for a while. Everyone is okay with this?
Okay, sir.
Yes.
You can see, right, where did the 6, 18, and minus 2 came from? This is actually B. And this part is A. X is hidden here, and this is B. Everyone okay?
Okay, sir.
Okay.
Okay, sir.
So now you have this matrix, and what we learned in the matrix algebra was that even if you swap two rows, add two rows, scale with some row, the solution does not change, right? And this is also you can do all those things in the Python programming too. So you have this swap row. What it does is that, okay, so just see how you want you can write swap rows. So you have this A is a matrix, and you have the kth element and lth row, kth row and lth row. You want to swap these two rows, and what you do is that you first find the shape. So what is the m number of rows and n number of columns? So shape is 0, comma 1. The shape is a tuple that we did before. If you want to write a dot shape, it will tell you 3, comma 4. It's of size 3 and 4 rows. So you have 3, 4, m is 3 and n is 4. And you first create a copy of A, like you literally copied A into some A matrix B, and you swap. Like you want to swap the kth element and lth element. So let me see what is A is this matrix. And you want to swap, say you want to swap this 1th element and 2th element. So you want this uh, first this element, the 1th element, to move to the first place, and this first place element to move to the second place. This is what you want to swap. So what you do is that you actually go for each element in the column. So you choose bk and the jth and the jth number in a temporary variable, and the bk. Okay, so this is, I think this is, this is okay. This is okay. So you take the bth element, bkj, the kth row and the jth element in that row in some temporary variable, and you replace the k comma j element with l comma jth element, and the l comma jth element should become the k comma jth element. And if you keep doing it for the entire row, you will get the B matrix. I will show you that what it becomes. So let me just close everything. So we have swap method first. So let's just do swap first. So we want to swap. Uh, A is this. A is this element. We want to swap 0 and 2. So you want to swap the 0th element and the second element. So two, remember that the counting is from 0 to 0, 1 and 2. So we want to swap this row and this row. Let's swap them. We call this function swap 0 and 2, and this is what we get. So we want to swap 0 and 2. So you can see this element went up and this element came down. Everyone is able to see this?
Yes, sir.
Now look at this equation once, that everyone is able to follow this for loop. What is happening between this? It is taking each row element, the kth row and the jth element in that row, and then storing it in a temporary variable and then changing the values. Okay. If it is difficult, I will be sharing this tutorial notebook in the Discord channel today, so that you can go and see yourself that this swap algorithm, though swap function. Similarly, the scale function is very simple. What you do is that you first make a copy of B again, and then each element, each row element. So you have this each element, this 2 should be scaled, 1 should be scaled, 8 should be scaled, and 18 should be scaled. And you go to each column. So n is the number of columns, right? N is the number of columns. So for every column element, you just multiply with that. Okay, let's use this scale into this, right? This, you want to multiply this scalar number into this number, and for all the column elements, right? So let's do row scale. So let's do row scaling. So you have the scale and you scaled it. Okay. And this becomes this. So you have this A matrix looks like this, and you scaled the row 1 with 2. So you see 2 to the 4, 1 into 2, 2, 8 to the 16, 18 to the 36. Everyone is able to see scaling?
Yes, sir.
Now at least look at this function row scaling. What is happening is that for there are n columns here, and you want to scale the kth row. Kth row you want to scale with the scale function. So you choose the kth row and the first element in the kth row. So if the kth row k is here is 1, the first element is 2, and you multiply 2 into the value, the previous value of this 2. The scale into 2 becomes the new element, plus your for loop is there. So you go to the second element 1, and you multiply scale into 1, the third element 8 into scale, and then 18 into scale, and then for loop ends because it went through all the number of column elements. Everyone is okay with this part, at least the scale part?
Okay, sir.
Okay. So now the scale is, this is how you scale. Now we have add. Similarly, if you want to add two values in a matrix A, kth row and lth row, and you want to scale and add. So what you want to do is that you first copy B into A, and then you want to add into lth row the kth element. You want to add, say for example, in this case, you want. So let's do an example here itself. Though. Just a sec. So let's do this. So you want to add zeroth row into 2. Actually, let's do first. You just simply want to add. Scale is 1. So for the time being, just forget about the scale 1. You want to add zeroth row into 2. So zeroth row is this, and 2th row is this, and you want to add these two. So 2 into 4, 2 plus 4 is 6. 2 minus 2 plus 2 is 0. 2 minus 3 is minus 1. 6 minus 2 is 4. Everyone is able to see? You want to add the first row into the last row. You can add using this. Now, if you look, let's go back to the equation and how they function, how they are doing. So you have m number of rows, n number of columns. You first create a copy, and you want to add every element in the column, right? You want to add every element in the column with every element in the kth row. So what you do is that you took the first kth element, k comma j. Scale is, for the time being, assume scale is 1. So you took the first element in k comma j and added it to the lth row, l comma j, right? And scale is simply that, remember that we did this 3 times row and then you add this 3 times, we did the 3 times row and then added it. So this is what it is. It is scaling the row and then adding it to the bth column. That's it. The scale here, what we did was just simply scale. Now here we are doing scale and add. Here we are scaling it and then adding it. So you scale it with this and then add it to the lth row. So currently the scale is set to 1. So it's basically simply adding kth row to lth row. That's why the scale was 1. If I make it scale equal to 2, say make it, if I make it minus 2 and then do, so you can see it will first make 2 into minus 2 is minus 4, plus 4 is equal to 0. Minus 2 into minus 2 is 4, plus 2 is 6. 2 into minus 2 is minus 4, minus 3 is 7, minus 4 plus minus 3 is minus 7. 6 into 2 minus 2 is minus 12, plus minus 2 is minus 14. So scale is just scaling it, the kth row or zeroth row with minus 2 and then adding it to the second row. Everyone is okay with this part?
Okay, sir.
Okay. I think I just want to finish this tutorial first, and then I will. And if I am going fast, please let me know. And I think, okay, I don't. I think I want to take some questions later on. So this is very simple. Now we remember what we did here. Like we converted all these things three into row, and then we added, and then we converted into this form. And once it became into this form, then we know the value of x is simply 32 by 5. So we will do something similar through this form. So I think I will just leave this section to you. It's simply just, it says that you know want to add 0th row and 1th row and scale it with -2 and all those things, and it converts into this nice form where you know the value of x is equals to 2, and then x3 is equal to 2, and then find the value of x2 by just simply putting in this equation, and then by putting into this equation you find the value of x1, x2, x3. Okay, can someone tell me what is the value of x3 here, at least by looking at this matrix? So we started with this complicated matrix. What is and we reached the here by doing all the row operation. What is the value of x3? Just tell me the value of x3. Can someone tell me the value of x3? You know that by doing all the row operation, multiplication, addition, subtraction, the solution never changed. So all these matrix that you see here, the solution of x1, x2, x3 will be exactly the same. It will not change, right? We saw this thing, right? We saw this thing here. By performing row operation and adding, subtracting, it did not change. So similarly, we are doing the same operation here, and we found this matrix, and all the matrix solution is exactly the same. What is the value of x3? Okay, so if you're not able to see, let's do this. So 0 into x1 is 0, 0 into x2 is 0, 1 into x3 is equal to x3, and this equation is equal to 2.
Sir.
So x3 is equal to 2, right? Because every other term is 0.
Yes.
So you can see this matrix, interesting matrix, right? So it became like x3 is equal to 2. That's it. And once you know x3, you can find the value of x2 and other values. So this is how you can do. So I will just leave this part to you to understand how you can do manipulation and convince yourself that doing all these matrix thing, row operations does not change the equation. Okay, so rank, I will just leave this part. Okay, so you can also solve by solving A inverse B. So if what you do is that you have this matrix A and you have this matrix Y. This is AX equal to, okay, let's write it B in the same form. AX equal to B, and you can tell that, okay, you can pass it to the linear solver saying that AX equal to, solve this form, and this matrix they will solve and find the value of x. It will directly solve the value, because to find the value of x, x is equals to A inverse B. So it will calculate A inverse B and then give you the answer. And you can do it by yourself too if you want to see. So you have this A inverse. A inverse is equals to numpy of, you call this function numpy into linear algorithm into inverse of A. So it will calculate A inverse, and to find A inverse into B, you do A inverse. This symbol at the rate is the symbol of matrix multiplication. Remember, matrix multiplication is different than simple multiplication, right? You have this row operation and column operation that you have to do. This is matrix multiplication into B, and you do this and you get the same solution. A inverse into B. You see, it's the same solution, right?
Yes, sir.
So if you can write the matrix A, solving for B is very simple. So you can also do this thing. So you can let's do this solution too. Now since you know how to write A, so tell me this part. We'll do one example before we end the class. Let's do this thing fast. So what is the value of A? How should I write? np dot array the first thing, what should I write? The first column. 2 minus 2, sorry, 2 minus 2 and
Yes.
2 plus 2. This first row. The second row, what should be?
2, 1,
218.
2,
8,
1, 8. And the third row,
4,
2 minus
2
3.
minus 3.
4, 2 minus 3. Right?
Yes, sir.
Okay. What is B? What is B?
6, 18
18 minus
minus 2.
NP dot right? Okay. You go what? 6,
6, 18
18
minus 2.
minus 2. Everyone is okay with this part?
Yes, sir.
Okay. So everyone is clear this part, right? So now let's find A inverse. So A inverse is equal to NP dot linear algorithm into inverse of A. So we are able to find A inverse. So if people want to see how does A inverse looks like, let's see A inverse. You can see that it is not equal to A. Okay, A inverse is this interesting fellow. And if you see A inverse into A, remember the matrix multiplication? What should be the value of A inverse into A?
Sir, identity matrix.
Identity. Can everyone see this is identity?
Yes, sir.
Let's do A. So we multiplied A inverse into A. Now A into A inverse. What is the value of this?
Sir, either.
Is the same identity matrix. Remember, A into B plus is equal to B into A is equal to identity. This thing is equal to A inverse at the rate A. This is the same thing, right?
Yes, sir.
So multiplying the front or the back, it did not change the value. Okay, so everyone is able to see that this is a inverse because A into A inverse is the identity matrix. So you are able to find A inverse. Now what should I what should I do to find the value of x? X is equal to
A inverse B, sir.
A inverse sorry, A inverse at the rate B, sorry, so and print x, and you have the value. So you can see x value is 2. So the e power plus 10, 0, you can read it as 10 to the power 0. 10 to the power 0 is 1. So, and this is e power 10 to the power minus 16 is like 0 0.0. It's basically it is 0. 10 to the power minus 16 is like basically it is 0. And this is 1. So 1, 0 and 2 is the solution. So you can make it better though. How do I write it? Nah, okay. This is what the solution looks like. A first element is 1, second is close to 0. It's 10 to the power minus 16, which is basically saying is minus 0. It is 0. And 2 is 2. The third element is 2. Everyone is able to see 1, 0 and 2 is the solution. You can put this value 1, 0 and 2. So 2 into 1 is 1, minus 2 into 0 is 0, plus 2 into 2 is 4. So 4 plus 2 is 6. Right? The first,
Yes, sir.
the second element is 1, 0 and 2. So 2 into 1 is 2, plus 0, plus 8 to the 16. 16 plus 2?
18.
No, 16 plus 2 is 18. Okay. Now, for last equation, 4 into 1 is 4, plus 2 into x2 is 0, minus 3 into 2. 3 to the 6. 4 minus 6 is minus 2. Right? So you can see that even by doing this A inverse into B, you actually get the solution though. It's not, we are not, I was not joking though. You can really solve this equation just by doing A inverse B.
Sir, I have a doubt.
Yes.
Sir, why the minus 1 is taken as 0?
Where minus 1 is taken as 0? Or this part. It is not 0 though. Look at this equation. There is e power minus 16. So when you see this e power in this Python notebook, in Python, when you see e power minus 16 written like this, it means 10 to the power minus 16.
Yes, sir.
Okay. 10 to the power minus 16, and you have this number. You have minus 1.0. So assume this is the number. 1.11 something. Assume this is 1.0. It means 1.0 into this. So what is the value of this? It is, oh sorry, This is minus 1. What is the value of this? 10 to the power minus 16 is 0 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yes. This is the number.
Okay, sir.
Now everyone can see this is equal to 0, right? You can say it is equal to 0. Any doubt?
Sir,
Yes.
can we remove the decimal points? It is possible.
What decimal points you want to remove?
If the print text
Yeah, yeah,
1.00.
yeah, you can, you can. It's just that when you print X, it is actually just showing keeping all the decimals though. It is just it is making sure that they want to be very accurate as possible. That's why all these decimals are coming in. But e power 10 to the power minus 16 is like there are 16, 15 zeros though. So it is basically equal to 0, right?
Okay, sir.
It's very close to 0 is equal to 0. And e power plus 0. So e power 00 is 10 to the power 0. 10 to the power 0. And it becomes
1.
minus 1, right? Minus 1 e power 0 is minus 1 into 10 to the power 0 is equals to minus 1.
Okay,
Correct?
sir.
This part is okay?
Okay, sir.
That's why 2 into e power 0 was 2. This is just
Okay.
the Python notation though. Nothing to worry about. Everyone is okay with this part, right? I think I just want to complete one more and then I will end this class. Similarly, so A inverse B, we did it. So I think I will just leave this part to you. I think this part is not, this part you can solve it by yourself. Let me share this notebook with you on. So how do I, okay, I think I have. Give me 1 second. If there is any question that you want to ask, please ask. And I want to share this notebook. Please wait for a while. Let me upload this notebook in the chat so that people, students can see themselves that all these things. I was not joking. I was not lying. It actually works this way. So download. Can I upload such thing? Add a link. Do people know how can I upload anything here? Interesting. Acha, theek hai. I think I will share it in the WhatsApp group. Everyone is in WhatsApp, right?
Yes, sir.
So
Yes, sir.
I will share in the WhatsApp group. I feel like I'm not able to find how to upload here. Okay, let me upload. And someone, please stay online just to confirm. Someone can confirm that, okay, they can see. I can upload this thing there, right? The faculty there will not mind me uploading such thing there. I'm hoping so. If they say something, then I will not upload next time. Okay, I uploaded it there. If someone can confirm that they can see.
Yes, sir.
And you know how to upload these notebooks, open these notebooks in Google Colab, right? You know how to open these notebooks in the Google Colab.
Yes, sir.
Okay, if
Yes,
you don't
sir.
know, ask ChatGPT. Okay, so we can, if there are no further doubts, then we can end today's class and we'll meet tomorrow. Okay. Any doubt?
No, sir.
Okay. Thank you again. Thank you for staying slightly longer. We can end the class. Thank you.
Thank you, sir.
Mm.
Thank you.